All right, so we shall start the session since already it's too late to go through for the long time wait we can't do. All right, so in the last session we have discussed about like what is the battery management system. All along we try to understand how we can rectify some of the cause and some of the actual scenarios which comes around us and how it can be useful more in the way. So we'll continue on from that part itself, and I hope you guys must we have gone through with the recordings. So is there any recording which is missing from the shared folders which I have shared to you? Because I get a message from someone that he is going through with the recordings, but one recording was not available, that is on 4th of April. Have you downloaded all those folders? Anyone, can you please give me a confirmation in the chat box? I hope I am audible to all of you. Manav, Hardik, Krishna, Balaji, Kaushal, Shashank, Ashish, Navinder. So you got all those recordings? Okay, fine. Thanks, Shashank. Thanks for the confirmation. Right. So I'll share my screen and I'll do let you know that what are the things are still on the bucket, and we'll understand it today. So let me put my video on mute. So lithium ion battery management, as you can see, battery management system. So market options are available with us. Investigate BMS solution for highway capable EV conversion. So as a part of need of the moment, which we certainly requires to go through and develop such type of lithium ion battery which are capable to roll out the vehicle at good extent and at good speed also as well over the track. So that's why we certainly required the EV conversion. So that's a solution we need to find out how we can find out by the help of some supports in the DC system, that is your 160 Ah prismatic lithium ferrous phosphate, that is for lithium ion for 3.2 volt, then 250 amperes plus systems, 40 to 48 cells, 128 to 153 volts, must monitor, should manage, report and balance. So these are the certain we can say basic points which we need to keep in our mind while doing the selection of all those type of BMS. So let's have a elaboration on it. That lithium ion BMS options we could have Agni Motors Strikebrook Limited, which have the topology that is of distributed. I again review the type of topology which we have discussed in our last session on Thursday. That is about not on Thursday. That is on Wednesday. So we had discussed about three type of topologies. There were distributed, modular, and which is third one is missing here, that is your centralized type of topology. So we have discussed on three type of topology. Accordingly, we have to select the particular manufacturer, that which type of topology are they giving to. So if they are giving to us any type of topology, but have those all functions included in that or not, so that is a consequence we need to always trigger in our mind while doing the selection of your own car also as well. We need to check just for the reference that which type of BMS are they using, and for how much life cycle it can go up to. So these are the certain facts we always carry on, and accordingly we have to select any one type of BMS. So in the topology for the distributed from the Agni Motors, we could have number of cells about 1 to 200. Balance how much battery is balanced there during the depletion and during the state of charge. They will let us understand by the indications, either by the highlighting the particular red, color code, or else like they are just giving us indications. Temperature would not be available, display will not be available, fuel gauge will not be available, over volt protection will also not be available. Communication will be through wire, by putting up the wire. Case is up to you, either you have to choose which type of case you can just keep on that BMS that you have to choose. And its price approximately till 48 cell, it would be around $1,000. So these are the, like, wherever there will be not applicable, no, I will not conquer on that point, as like I discussed about the Agni Motors. Shall check with the black sheep technology, which having the modular type of topology, and number of cells is it's starting from the 4, and you can goes up to as much you requires. All right, so they will show you some different aspect, that is your for balance, how much battery is balanced in that indicator, Temperature also they will do let you know. Fuel gauge in the sense like they will give us an information during the charging process. During the charging process, they will let us know that how much fuel, that is your charge, is available into the battery. And since it's a EV, so we can just conclude as a fuel, that is your electric current. Then overvolt protection, yes, it will be available there. Serial type of communication will be there. So serial type, that means they are just moving on towards the particular microcontrollers. So plastic or metal type of case will be available with it. $2,200 will be applicable for 40 from 40 up to 48 cells. Then E-lithium, then EV power, both we having the distributed type of topology. But yes, they can able to give us all certain type of facts which are not applicable in other one. But one thing is there, like case will not be available for E-lithium, but yes, for EV power certainly they will give us a metal type of casing. So here we can see like the number of cells will be 1 to 255. So that means 255, that is a type of like till 255 number of cells. It won't goes more than that. So that's why it's having some consequences. So wherever you will find that there are some constant number of cells, so maybe some functions will be more than the other type of topologies or given by the vendors. Similarly, let's take a look on that. We have high tech systems, SSI, Ningbo, Yangming, Elite Power, BMS 50. So Pack Tracker from KJ Hall Motor Company. Pack Tracker is the particular, we can say by default, many of the e-rickshaw uh, developers have already taken up this type of topology. If they are making it for the high extent or for the high valued e-rickshaws. Likewise, Mahindra have just recently adopted ones. So such type of e-rickshaws which having the lithium battery, they are certainly taking up the track tracker. However, REAP systems, we have volt blocher. So most commonly we could have the modular type of topology, and some of them would have distributed type. Centralized type is moreover is not yet come into the market, but yes, it's in process and it will get developed until unless it should not get heat up due to the operation. So that's a thing like they need to keep in their mind while processing further for the BMS. So there are some honorable mention. That means the things which has been become as a type of extraordinary into the market of BMS. So you can see here lithium balance. No published specs for pricing will be there. Gary Goodrum, that is for DIY BMS circuit. 24 cell on endless sphere low current device for bikes. Metric Mind, that is for custom BMS, no pricing for BMS products. Boundless creates custom battery packs. Hot Juice Electric BEQ, balancer only they are creating. Manzanita Micro, that is for partial solution 4 cells for $250. Open source BMS projects, no resolution. So certain are the particular honorable mention, or we can say the extraordinary they had gone through, where they can think about the economic thing, economic charges, and they can be able to rationalize that how much they will put up their own extent and the material. Accordingly, they put the pricing also as well. Small print we can take up for the lithium ions. I would suggest that you should guys can go up with this slide and just read it thoroughly at your own. Just I'm giving you a summary about it, that what basically going on here, that there is an organization who actually deals in lithium ion BMS. They certainly make a particular whole structure of the BMS, and they're trying to possess that which type of technology we have adopted, either into the term of analog or in the term of digital. Then after that they can show that which type of indications they will come up either into the form of SOC or DOD, that is for state of charge or depth of discharge. According to this format, they can able to calculate that how much battery is remaining there and how they can approach for the balancing further. So BMS calculation will be done by this formula. Then communications will be based on their wire, CAN and RS-232. So as we had just discussed about in our previous session, that how the particular wiring will be connected to the slaves, and from the slaves to the particular master control unit. Accordingly, our RS-232 is the type of microcontroller who would adapt the number of signals, and accordingly they possess further for the working scenario in the BMS. So these are the particular manufacturers and their clients they can have to think about. Now, one of the particular best organization who deals in BMS well, that is for Hardy EV Flex. So this is the organization who made a centralized BMS architect, miniature in-car display and operator alerts, battery monitoring for over voltage, under voltage. 3 versions in production they have, that is for up to 36 cells for no emission electric vehicles, no emission vehicles and small EVs, up to 48 cells for DC systems, up to 84 cells, that is for Prius plug-in conversion and AC systems. So Toyota Prius have already adapted from Hardy EV while they have made a HEV. During that time, Hardy EV Flex was the company or the organization who deals with the Toyota. Temperature monitoring is available there. Adjustable voltage and temperature thresholds can be get done. Cell balancing with the built-in thermal management. Full diagnostic self-test. Identifies faulty wiring. Internal log allows identification of problem batteries. USB log option for detailed cell monitoring logs. Current monitor option for state of charge determination. Works with charger up to AC, up to 25 amperes to 40 volt. Priced for EV conversions is approximately of your $891 for 48 cell system. Data logger option for $50. Current monitor option for $60. So these are the circumstances, and we can think about the financial things which will come around while we are doing discussion about the battery management system. Project's objective we can take further for the RESS. So into this project, what are the aspects we need to always carry further? So on that aspect, we will be having a discussion, and we'll do let you know that what is the actual working of RESS system. Give me 1 second. So delineates the hazards and their severity levels pertaining to the functional safety of automotive rechargeable electric energy storage system, controls and identify safety requirements and constants of battery management system functionality. Define system diagnostics, prognostics, and data logging. As we all know that diagnostic is the process which we supposed to do during the fault occurs into a car. What about prognostics? How can we able to understand what is prognostics? Data logging will be at a type of transmission media which is done towards the central your ECU or like central controller of the EV. So what is the particular prognostic word defines to us? So this is the open question for everyone. Anyone can participate on this and put up me the answer. What do you understand by this term? That is prognostics. What do you understand by this word? Anyone can unmute himself, or else like he can put up into the chat box. I'd like to check that. What do you guys are able to understand by this term? Progression of the data is known. See, that is the type of word you are using here that come into our language development and or coding, we can say. But prognostics is a word which is going to be defined into the entire vehicle inspection. So by taking into a reference that during the inspection of a car to find the fault, then how the particular diagnostics and prognostics are differ to each other. Manav, see, during the diagnostics also we can able to find the indication and some faults which are available, and we need to rectify it within the time period. However, prognostics what does? Yes, exactly. Rajat Shetty have said well that the prognostics is the futuristic thing, like how the particular fault has been occurred in front of you at the present situation, you can rectify it, but what will gonna happen afterwards and how the particular fault can be get resolved during that situation, that is as per our past experience we can able to rationalize and we can able to possess further that how after how much time, like likewise your vehicle has been repaired and just to get out of the workshop and afterwards you are using there, but meanwhile you just found there is I meant to say that there is a kind of issue with the vehicle which came around in the future. So the particular issue which generated into the future after the diagnostics process, so that particular faults which maybe can occur and it has been already being in knowledge of the particular manufacturer or OEM, then they could be able to knows about it very well and they can able to access further. Right. So, Jagan Mitran will share you the particular recordings once again, and I hope you should be cope up with that, and I hope you are able to check the WhatsApp chat box because you are already added there. So I hope you haven't missed any one folder from there. So identify safety critical information needs and effective methods to communicate this information to operators or the driver of the vehicle. Address safety related instructions and training needs for operators. So training needs for operators will be managed when the particular workshop having the vehicle to be repaired, and that technician should have the knowledge about that car repair work. So such type of trainings are going to be given to the operators or the particular technician. The safety concept is the main part, vehicle energy management functions. So we'll have a look on it, and we'll put a dig on it, like to get a better clarification that battery management controls what does that measurement and protection of an automotive RESS, specifically the BMS and its interactions with other vehicle systems. Fail-safe response to faulted conditions, diagnostics or prognostics, sensor validity or integrity, cell voltage, cell temperature, and cell balancing. So, particularly, these are the particular certain facts on which we need to discuss, and accordingly, our all controllers will be in work. So, after understanding of all such basic terms which are already available into our RESS, help us to work on MATLAB while we are doing the simulation of a car design or the particular technology which we are trying to develop and implement into the market. So refinement of the analytic scope. See, this is the particular whole picture or the particular whole cycle of the RESS. However, we are just going to discuss on each and every part of this RESS. All right. So I will not bother you guys to go through with this all bulky data. We just certainly make it simplified, and we can try to understand here. So refinement of analytical scope, we can check here that your high voltage DC bus is connected on site. However, this is the internal system of your battery management. We could have the battery pack aside. So battery management system will be internally, and from the outside your battery management system controller will act. Power distribution unit will be based on your particular clutches which certainly requires whenever there would be any electric car is going to be operated. During that situation, how the power is equally distributed, we need to understand as per the force applied on the tires and during the rotation of the tires. Sorry. Then every signals are meant to be provided to the power distribution unit from battery management control or data and current sensor. By this method, they can able to adapt, and they can have an ideology that how the power will be distributed well on it. So DC bus will always activated and connected to each other from the battery itself. And you can see from the downwards, we have the load management, resin management, charger management, thermal management. So these are the particular management is meant to be done by the controller, BMS controller, and certainly they can provide us the detailing through the CAN bus method. Through the CAN bus, you can accept the data and you can able to check that how much temperature of the particular battery pack is there, how much charge is remaining there, and how much load is going to be adapted on this battery pack. That could be available on this. On the right side, you can see that coolant and vehicle to the ground. We need to, it's by default basically in any car, either it's a conventional car, petrol driven or electric car. We certainly use the vehicle to the ground. Then we have coolant. So coolant is a particular glycol jelly we are using into the battery pack of electric vehicles. Now, automotive RESS, what basically suggests to us in a very basic terms, here we will understand. System description could have battery pack, battery management system controller, and power distribution unit, which I've just seen in our previous slide. Right. So these are the main factors of the description. Now, the function, how basically it works. Stores, see, automotive RESS is not only for the monitoring of the current, battery pack health, or the thermal conductivity. It's also give you the safer side, like how the particular whole battery system or the power distribution unit is supposed to be at a safer end, and we can able to give them the supports to should be at the safe side. Whenever there would be any impact to the car, it should not get hampered, or else like internal fault will be gonna happen, due to which there might be chances as like we are seeing nowadays Ola scooters are going to be burnt out totally. What is the reason behind that? We just certainly checked out and we just go through with that. So the particular BMS we certainly have to check thoroughly, because it's very highly flammable also as well during at high temperature, and this actually happens with the Ola scooters. Stores electrical energy received from the charger or the vehicle. This is the first function. Delivers energy to the vehicle systems. Communicates with the other vehicle module for proper vehicle functions. Maintains safe vehicle operation. So if vehicle operation is on the safe side, then definitely your other things is not to be bothered. Battery pack we can see here. Description and function. Now each of the particular aspect which we have just taken up, battery pack, then power distribution unit, and controller, we will be having an understanding how they are connected to each other and how they act basically. So sealed vented box we requires into the battery pack, includes the battery modules, voltage sensors, cell voltage balancers, temperature sensors, condensation sensors, and ground fault detection circuitry. So into this circuitry, we could have the cell voltage balancer, temperature, ground voltage, fault detection, and condensation sensor is on the one side. Then after that, we could have the battery cells, but number of battery cells which are already applicable there, the number of slaves in which those all cells are packed well. Then it could have the vent, connects, and thermal control. Thermal control can be get done by the help of this thermal functions we supposed to check with. Then what basically does your battery pack we all knows very well, but some of the things we can add a new part, like it stores electrical energy, delivers electrical energy, communicates cell status and isolation status. Battery system management controller, what they should does, you can internally you can see that how they basically are connected to each other. They start with the charge control and end with the condensation monitor. So into the charge control, we could have to understand like state of charge algorithm, state of health algorithm, high voltage controller, then PDU controller, power distribution unit controller, thermal controller, then CAN module, that is for control area network. Diagnostics and prognostics will be attained there. So diagnostics into the present scenario, prognostics for the future. So cell voltage monitor and balancing will be there. Load management, ground fault monitor, data storage, this all will be come into our BMS controller. So BMS controller is a type of heart of electrical vehicle. So description and functions we can check out. Algorithms include state of charge of state of health, diagnostics and prognostics, communication, data storage, safety controls. These are the particular description. How the particular the functions can be get managed. So manages the energy in and out of the battery pack based on the SOC, acts on safety related requests from other vehicle systems also as well. So safer cars, safer drives, and safer roads will help BMS controller to act in actual condition and well-being. Power distribution unit, you can see here that those are the particular relays and fuses which we haven't touched yet in any control units that will be available into our power distribution unit. We have main contractor, pre-charge contractor, relays, and fuses. However, description, we could have main contractor, pre-charge contractor, relays, and fuses. We all know that relays and fuses are what meant to be and how it can be get rationalized. Functions we can have here, controls connection between the battery pack and the high voltage bus, ensures that the system power limits are respected. So that means your system is in a type of like we can say savior for us is the PDU. All along we already gone with the particular battery pack and BMS controller. However, PDU will also define a crucial role into it, which actually help to keep them safe, and we can generally operate at well extent also as well. So interface we can see here how the interfaces are there for the RESS. There are some obliques. We can see the HVDC bus having the red color, CAN bus for the green, the dedicated CAN bus, that means only point-to-point connections are available. Input and output line is for black. Coolant is also there. Now, according to this particular slangs, we can try to understand here how they are connected to each other. So your charger controller will be the primary part, and then we have the RESS internally, that is for your rechargeable energy storage system. PDU, battery management and battery pack will all include into it. Basically, they all are get connected towards our outer other accessories which are already available. Likewise, HV system, high voltage systems, those accessories or interior we are using for the high voltage, they can also monitored by this HV system. Vehicle system controller, the particular traction during the driving condition, how the particular ESP or ABS can be work on it, that can be get fulfilled by the help of vehicle systems controller. CAN based controller and devices, then HVIL loop and thermal control. So these are the all aspects which become as a type of add-on feature for this RESS external interfaces. Internal interfaces we have already discussed, in which we had power distribution, battery pack and BMS controller. Now, if we come to know about the external interfaces, those all are here. HV systems, vehicle systems controller, CAN based controllers and devices, HVIL loop and thermal control. Scope of external interface, that may be that highly flammable and high voltage danger also available. So we need to always analyze the particular impact on the safe operation of the RESS and check the interfaces are duly packed well, and there should be no any open area which may suffer afterwards. So there are some sign we can use, that is danger, high voltage, certain facts we can show, then people will be aware, would be aware that this should not be get impacted from anywhere, and it should be on the particular safer side only, due to which the such type of fire cause should not happen and it will be in our control. Diagnostics trouble codes, if we try to understand into our electric vehicles, so there are some certain patterns which suggest to us. There are miscellaneous type of, we can see here, it's about 1%. Communication type we can see here, that is for your 8%. Contractors type we can see here, for that will be your 17%. Battery and electronics cooling, that will be 3%. However, no, that will be your 35%. Yes, because battery cooling is the very crucial part. Then HV battery diagnostics we can try to understand, that would be your 3%. So these are the particular percentile which trying to give us a information that at what extent there would be the issue with the electric vehicle may occur, and how those particular faults can be rectified. This should be mentioned from the OEM or the manufacturer while they are delivering the car. Communication and messaging, identify safety critical information, needs of owners and operators. Describe effective means to communicate this information. Describe barriers to effective communication and opportunities to remove them. Now, as per the topology, whatever we have learned yet, now we can see here that how they have used into their vehicle during the indication terminology is need to be triggered out, and how the things are monitored there. So we'll divide it onto 4 topics: system status, charge state, low charge, discharge rate or range. BMW Mini battery electric vehicle, it could have system status, charge status, low charge, discharge rate or range. It can be applicable. Chevrolet Volt, that is your plug-in hybrid electric vehicle, that could they can give you a plain English fault information, that if battery too cold or plug-in too warm, then your particular charge state, that 32 miles, how much kilometer can be or miles can be get driven, they will show you the particular value that it can goes up to this much. And discharge rate, They will also show you that how much voltage has been dropped and how much voltage has been consumed and how much are available. Karma, they have also the particular BEV plus type of. They can have the particular low charge indications. They'll show you the fuel and electric charge. Then range extender, they will, as per the range also they will inform you that how much battery it can be get driven. Nissan Leaf battery electric vehicle. They can also have the system status, charge status and low charge. Tesla Roadster, they can have the system status and charge status. Toyota Prius PHEV, they could have those charge status and discharge rate or range. So it's look like similar, but yes, the most 2 or 3 information has been already mentioned into the single form. So this is the particular BMS system which we're trying to understand since our last 2 to 3 sessions. All right, do you have any query to ask regarding the particular BMS? Say yes or no in the chat box. So I would get the confirmation that I do not require to put up on BMS system moreover. And I hope I have cleared you all the information, and I hope it would be helpful for you. All right, so Manav and Navinder have given me the confirmation yes or no. No, you don't have any query, they don't talk. How about Hardik, Krishna, CH Kaushal, Arun, Ashish, Shashank, and Raju? All right. So I think there would be some network glitch because you are not able to listen to me on time. That's why there is delay in message. No issues. Shall consider this one also. So it's 8:42 now. We'll take a 10 minutes break. We'll come back at 8:52 and then shall start further on MATLAB. That how the particular on MATLAB the simulation can be get done by the UI. So this is the type of recorded session I will show you and explain you that during the input from the beginning how to cover up and how to complete at the end. In between the changes whatever you can make, that also I will let you know. Yes, Manav, I will provide you MATLAB software also as well. So by going through with this recorded session, you can apply it on your particular software. So shall give you the particular MATLAB software by tomorrow. So we'll come back at 8:53 now and shall start the session again. Please be there and take a 10 minutes break. All right, so let's continue with this. So there are some key factors we need to come up, and accordingly this will be get processed. That is physical component models at various levels of fidelity are necessary for HEV development, that is for hybrid electric vehicle. However, motor is the main concerned part, and certainly we have the engine that should be downsized. So by keeping our eye on these all two key objects, and we need to understand that how much capability will be applicable there. So modeling the plant and controller in a single environment enables system level optimization. So a system level optimization can be get done and can give you information that how much we need to economically check with, and just certainly understand the parameters values, and this will be get done by the integration with MATLAB and Simulink enables efficient post-processing and deployment. You can see here we certainly have the HEV test report in which we'll see the speeds from the drive cycle. It would be always into the square waves. Then we can able to put up the C code which actually help us to understand during the simulation of aerodynamics. So how the particular vehicle is speeding running through and how the chassis is reacting on it. All right. Going forward towards the MATLAB understanding, why not let's take a look at what MATLAB is meant to be nowadays and how the things are apparently changing day by using the MATLAB based design and Simulink. Right. So let's take a video look on this, and this will help you to understand where you are if you are using the MATLAB and how you can able to reach up to those extents which really applicable and more in demand in the upcoming time through the MATLAB in the automotive world. Let me share the media.
Intelligent systems drive the technology of daily life. They're powered by megatrends like electrification, connectivity, autonomy, and artificial intelligence. As these systems get smarter, the software embedded in them incorporates ever more powerful algorithms. For example, an autonomous electric car with its advanced propulsion, perception, navigation, and safety features will run on an estimated 250 million lines of embedded code. Developing this complex code requires the use of system models throughout the design process. At MathWorks, we've perfected such an approach, model-based design. And we've created software tools that give you the power to innovate by making it easy to try new ideas, exposing design problems early, automating steps such as code generation, and speeding up the overall development process. Model-based design begins with a system model where you capture ideas and requirements. The model is an executable specification that lets your team collaborate across engineering roles and modeling domains to quickly explore design trade-offs. You simulate the model on the desktop or in real time to verify your design meets requirements, reducing the need for expensive prototypes. With each iteration, you refine the system model to optimize your design. When your design is ready for implementation, you generate code automatically, which eliminates hand coding errors. Finally, you verify your implementation through simulation, processor-in-the-loop, and hardware-in-the-loop testing. By moving design tasks from the lab and field to the desktop and cloud, model-based design is transforming the way engineers and scientists work, and it's advancing research and engineering education at thousands of universities worldwide. Learn what model-based design with MATLAB and Simulink can do for you.
Right. So I hope MATLAB, just briefing I tried to give you through this video, and let's take a look like how we can able to understand into more better understanding about this process on MATLAB, or you can say the MATLAB and sorry MathWorks, or you can say the particular Simulink. So let's me share my screen. So a hybrid electric vehicle report, test report we can get during the life cycles. Our agenda would be that overview of hybrid electric vehicle modeling, electrical system, mechanical, thermal, other domains, mode logic and control systems. All right. So simulation and post-processing would be depending upon optimization and parallel computing, report generation, power quality analysis, deployment or integration, local solver or code generation. So what basically is meant to be here is for the overview of hybrid electric vehicle, we certainly have a model which is already by default adaptable by the MATLAB. We need to just get the particular model onto our workbench, and then we start modeling as per our own convenience or as per our need of the moment. Like in the modeling, what are the changes and what are the effects we can make up, that will be depending upon some certain factors. Those factors would be electrical system, mechanical, thermal or other domains, mode logic and control system. So these all are the certain facts. Then we come up towards the simulation and post processing. During the simulation and post processing, we need to come up to understand the calculation type, like where the particular calculation should be computed, and can give us a understanding, because certainly it happens that we took a particular measurements at initial, and accordingly we are just measuring those all concerned parts of the electric car or HEV or a hybrid electric car, and accordingly we are just try to complete the whole process within the certain time period. But during that time period, somewhere it happens that we could not be able to compute or calculate the whole data logics which are just going in the parallel. How it can be get done, that is also will be applicable here, because softwares having the accuracy all with them every time. So those accuracy can be get developed or should be checked well during every stage of the work. Report generation after completion of your model which were you are trying to make, and and at the end we are now in the moment to check with that how the particular voltages will be get differ on that all, and the particular power generation and the power quality, actually the DC which we are trying to give on that battery pack, and accordingly we need to process further. and during that conditions, is there any gap or any fluctuation or any glitch which may hamper your whole the particular model which you have made, right? So in that aspect, we can come up with the power quality analysis and deployment or integration. What happens basically here is, as per the model you have prepared in a simulator, and after the simulation, things has been done. And you are now have a understanding that after implementation of such all technology into the physical world, then how they will be reactive to you. Either it will be a local solver by using the CAN or by using the LAN or as per the system which we generally requires into a car, or code generation. Code generation in the sense, see, coding, there are two ways to do the coding. First is by using the particular language, either it's a PHP, Python, Raspberry Pi, Arduino, there are many more. Or else we not need to bother about the language from where it has been came to us. We just have to focus on that this code, if we put up into this control unit and we try to rewrite the particular same control unit as per the program, then this control unit's fault will be removed out from there and it can be reusable. Or we can say in other word that the simplest form of making any control unit durable for the long concern. That's why SCN coding is going on. During the SCN coding patch, we are not going to learn about that what is going to be happen by the help of Python or any other language, because it's a mechanical plus electronics. There is no need of CS or IT. But meanwhile, integration, during the integration, if you are only into the programming part, then you have to go through with certain languages, and accordingly you can develop a particular embedded or the whole scenarios, and then integration will be followed by the particular mechanical engineer or electronic engineer. Or else, if you have the capability of the understanding before the programming and after the programming, the particular whole control unit which is used for the particular traction control or any drivetrain, how they possess and how they basically works, if you knows about this, then definitely it will be helpful for you and you can complete it on the particular note. So into the MATLAB, we not need to just only come up with the language. We need to understand the tabs which which is responsible for what aspect. Accordingly, we need to understand further. So there is no audio at all. I'm just checking with showing you the particular slides and some working conditions into the MATLAB. So what I would suggest, you guys just take up the particular today's recording, and this video also I will share it to you. Along with that, I will take hardly around 1 to 2 hours. I'll share you the MATLAB software also. Once you go through with the particular software, install the software properly and try to work on this particular model. And as per the consequences, whatever the challenges you will face, you can just come up to me in the upcoming week and do let me know. I will help you out to understand. All right. So I'm just giving you some brief on it. And then today I'm not little well. So shall wind up the session at early. But don't worry. Tomorrow I will give more time on it and shall complete the whole session properly. So from tomorrow onwards, we are going to start with advanced automotive series. Meanwhile, you guys have to do this parallel work that is on MATLAB MathWorks. You have to complete this task also. If you want, then you can make it as your own project. If someone is eager to work on it on the MATLAB, he can make it into a type. Make it is it's a type of project, and I'll consider that project only. Anyone, any member can use it, and I'm not asking only for 1 or 2 guy. Those who are eager to work on it, they can start. So hybrid electric vehicle model, there are two concerns at the beginning. We are trying to understand here balance, fidelity and speed. All right, so balance fidelity in the sense that the particular power generation and the uses should not be differ. It should be as equal as much should be required. All right. So there are some concerns which are predefined by the particular software, or else like we can just change into the predefined values during the during working on MATLAB. Electrical and battery, we could have these two type of. In the electrical, we need to understand with the system level where we will do the test integration and optimize system. There we can use the particular motor and generator, how much it should be optimized and downsized. Then we have mean value, that is for three-phase electrical system, and then we have detailed, that is for test power quality. So power quality will be, you can see on the third last picture, where the engine is also included and it can be workful for. Now, then battery, we could have generic or predefined and custom models. In the battery, you could have the understanding that if you want to change the voltage or the type of battery, either it's a lead acid battery, either it's a lithium ion, then how much voltage is going to be withdrawn and how much going to be in use further during the working of this HEV. You will better understand during that situation while you are doing the editing apart. So what I will do, guys, just I will share you these all details today along with the recordings, and by tomorrow whenever we will start the session, I'll brief you at very not in the same like depth as I'm talking today. Tomorrow I will explain you in a very short format that you should be aware of the fact, and accordingly you can implement your own aspect and own skills on this MATLAB software. All right, shall we do this in this way? Because today I'm not feeling well because of the last 2 days. I was in trouble of the family issues. Now it's okay and fine. So by tomorrow I will definitely make sure I will complete this all briefing based on maths work, and then I will start the advanced automotive series that is for only for automobile, and that is for conventional cars from tomorrow onwards. So what do you suggest, guys? Should you guys will go through with this all today's training? Thanks, Manav. How about other members? Can you please give me a confirmation on it? Thanks, Raju. Thanks, Krishna. All right. So thank you so much, everyone. I shall share you in next couple of hours today's recording along with the software also. Thanks, Ashish. And shall come back by tomorrow at 8 p.m. sharp, and then start the session afterward. All right. Thank you so much for joining today. Good night, everyone.